Okay, so we'll need our calculators, but this is a pretty straightforward equation to solve. 27 times 16 is going to give us 432. Will equal 24x, and then I just need to divide both sides by 24. So if I divide by 24 there, I'll get 18 for my x. Yes. There you go, Peyton. Okay. Questions? All right, so that's your first type of rule that you'll see. The second is going to be when you have a secant and a tangent. Okay, so the tangent is this line right here that just is on the outside. That is the tangent. Oh, shoot. Let me get rid of all that. Here, let me write that again. This line right here is our tangent. And then over here, this line that crosses the circle twice, this is called our secant. And so the rule for this is that the tangent squared will equal b times b plus c. Now the way I think about this here for that b times b plus c is that this b right here, this is your outside. So b is that part of the segment that is outside of the circle. And then b plus c, this part right here, that is the whole line. That is, this whole thing. So it's outside times the whole segment. You could, in a way, even say this is the outside times the whole segment, because the outside is the whole segment, so it would just be a times a right there. But the outside part times the whole segment. So that part that's on the outside is the one that's going to be there twice. Okay, so let's look at setting this up. Which one of these would be my tangent? The 12 or the 9 and the x one? The 12. That's my tangent, right? So I'm going to say 12 squared is going to equal, and then I need the outside piece. What's my outside piece? 9, because this piece right here is on the outside of the circle, times the whole line. What would the whole line be? 9 plus x. Okay? Once you get this set up, you should just have an equation to solve. You could use Desmos if you want. If you don't like solving these by hand, you can use Desmos. But I'm going to solve this one by hand. It's 144 equals, we could distribute that 9. That'll give us 81 plus 9x. We will subtract 81. This will give us 63 equals 9x. We'll divide by 9. So x will equal 7. questions there? All right, let's go on to the next rule. So this time you have two secants that are intersecting outside of a circle. So you can see here that you've got A, which A is our outside piece, times A plus B, which A plus B right here would be the whole secant, right? And then for the other line, you've got C, which again is your outside, times C plus D, which is the whole. So you got outside times whole equals outside times whole for these. So for example 3, if I'm looking at, let's look at this line right here first. David, what's the outside part of that blue line? 6. What would the whole be? So what would I call the whole line right there? Not 6 times x, 6 plus x. Because we would just add the lengths of those two things together. So 6 times 6 plus x, that's this blue line right here. Now I'm going to look over here at the pink line. Peyton, what's the outside of that pink line? 7. What's the whole pink line?
5.
So what would the length of this whole thing be?
13. 15.
Not 13, 12. 12. You're just adding wrong in your head, though. You were doing 7 plus 5, right? Yeah. So you can write it that way. You can write it as 7 plus 5 if you want. Or you can just go ahead and say it's 12, because 7 plus 5 is 12. That would work also. And remember, I'm going to flip over here one more time to remind you guys, if what's giving you trouble is this part, like if you can set it up correctly and you're not solving things correctly, Desmos can help you with this. You need to do y equals the left side, 6 times 6 plus x. You need to do y equals the right side, 7 times 7 plus 5, like that. It's going to graph it. You're probably going to have to zoom out some, right there. We got 8 and 84. Which one is my answer? The 8. We use the x coordinate for our answer. Now, I'm going to show you how to solve that by hand, because it's one we should be able to solve by hand, but Desmos is always your backup on that. So if I do 7 times 7 plus 5, I'm going to get 84 right there. You can just type that into your calculator, or 7 times 12 is 84. I'm going to distribute right here, so I'll get 36 plus 6x. And then I need to get the x by itself, so I will subtract my 36. So 6x is, I think it's 48. Does that seem right? And divide by 6. So x is going to equal 7. No, 8. 8, 8, 8. What am I thinking? 8. 42 would be 7. Okay, questions? me a second. Somebody start writing. Okay, everybody good here? All right, so I want you guys to try this next page, right? It's more of the same types of problems. I want you guys to try to do these on your own. All right, so you can see what we have here. So, questions on any of these? When it comes to quiz or test time, and what I am going to do with you guys, since I got a few of you going on that field trip tomorrow, we're going to do our check-in Thursday. So if you are gone tomorrow, we're going to do some notes and Delta Math on that. Those notes and Delta Math will not be due until Friday, because Thursday we're going to work on our NC check-in. So that you will miss some instruction, but it'll give you an extra day to get that made up there, since we're doing that. So remind me So on these, when it comes to quiz or test time, the quiz is probably going to be Friday for you guys. I may do it a day early for my other class because nobody's going on that field trip for them, and I think we're just going to do our check-in tomorrow. But it's important on your on that to write down at least the equation at the top there. Some of you are doing this all on Desmos, so you have like nothing written down, which is okay as long as you're getting them right. But if you don't get them right, you will get 0 points. So what I would suggest, if you are a Desmos solver here, is whenever you are doing these problems on your paper, at least write this thing. And then you can solve it in Desmos if you want. That's fine with me. I don't have to have work for it. But if you write this down, I can give you some partial credit, because if you type it into Desmos incorrectly, or you accidentally type in a 12 instead of a 13, you're going to get the wrong answer, and then you will get nothing if there's nothing on your paper. So I would highly suggest at least writing that equation down, because you'll probably get half credit if you set up the equation correctly, because that's really almost the biggest part of this. Okay, anybody have any questions on any of these? All right, let's keep on going. All right, so congruent chords. So if two chords are equidistant from the center, they are congruent to each other. The line perpendicular to the chord bisects the chord. So some things that we must know here. In this picture, a chord would be A, B, and our other chord right here would be C, D. So if these two are congruent, or if they are equidistant from the center, so they're the same distance from the center, so if this like red line here is the same length as this red line here, then the chords have to be congruent to each other. Okay, so that's important to know. There is also this other piece of information that tells us that that line that's perpendicular to the chord, this is going to be the distance from the center. If this line perpendicular here, it is going to cut that chord in half. So this piece right here would be equal to this piece right here, which means this piece right here is also equal to this piece right here. All four of those parts are equal to each other because these are the same length here. So sometimes this can be used where you have two chords in a picture, but what you're going to see more often are these types of problems right here. So you have a chord, this line right here is a chord, and then you have a line from the center that is perpendicular. So that is going to cut that chord into two equal parts. So this piece right here is congruent to this piece right here, which means this little piece down here is 9.8 also. Then they ask us to find X right here, so this side across from that right angle. What should we use to find X? Yes, Pythagorean theorem, because that makes a right triangle. So in a lot of these problems, you're going to have right triangle stuff that you're going to do with it. So what is my hypotenuse of that triangle? Is it 4.8, 9.8, or the X? X. So I will do 4.8 squared plus 9.8 squared equals X squared, and you're definitely going to use your calculator for this. 4.8 squared plus 9.8 squared is going to be 119.08 is going to be your X squared. and then you need to square root both sides. And when you do that, you should get that x is going to equal 10.9124. I can't remember on your worksheet. It probably tells you around one decimal place. It seems like these worksheets usually do. But I'll just keep the whole decimal. I don't ever mind if you keep extra decimals, except for maybe on Canvas, because sometimes Canvas doesn't like it. But worksheets, it's always fine to keep extra. Okay, questions there? All right, let's keep going. All right, here's a couple more properties that we have. A tangent line is perpendicular to the radius drawn from the center to the point of tangency. So if you have a tangent line is that line that just touches that circle at that one point. If we draw a radius to that point of tangency, it will always be perpendicular. There. Okay. It is also true, over here another property, two line segments that share an end point and are tangent to the same circle must be congruent. So if I have a tangent line right here and a tangent line right here, then these two tangent lines have to be equal to each other. That kind of makes sense, like it looks like those two should be equal to each other. So let's look at what types of problems we'll get for these here. All right, so here is our first example. They give us this side, and they're asking us about a radius right here. This looks like a right triangle. Do I know it is a right triangle? It's not marked, but this line right here is a tangent line that only touches the circle at one point. This line right here goes from the center to the edge. That's a radius. So even though it's not marked, we know this is going to be a right angle. So we can't find that radius, but we could find the length of this whole side. I'm going to call that x right there. And then we just have to cut it in half to find the radius that it's asking us for. So for this one, David, which one is my hypotenuse? The x, the 8.4, or the 14? 14. So we would say x squared plus 8.4 squared equals 14 squared. So x squared plus 8.4 squared is 70.56 equals 196. We would subtract that 70.56. Let's see. 196 minus 70.56 is going to be 125.44. And then we got a square root. Both sides. We're going to get 11.2. Actually, oh, I circled that. Is that my answer? That is not my answer, because that is the length of this entire diameter. The question only asked me for the radius. So what should I do to my answer here? Divide it by 2. So if I do 11.2 divided by 2, 5.6, and that actually is going to be my answer. Okay, let's look at 10. 10, I've got two tangents. So what do I know whenever I have two tangents? We just marked it on that last one. What do I know about these two tangent lines right here? They're equal. So that 2.1 is really a distractor there. I could just say x equals 2x minus 3. Now to solve this, I'm going to subtract that 2x. Even though it means I'm going to get a negative, I like to do that more because then I don't end up with nothing on one side. And then I could divide by my negative 1. And so x would equal 3. I'm going to skip 11 for the sake of time. It's the same thing. You're going to say 4x minus 12 equals 2x plus 12, and you're going to solve for x there. Now, 12 looks a little bit like the outside times the whole stuff, but does this go all the way across the circle? It does not, so that is not the stuff that we were doing before. I have a radius and a tangent. That's going to be a right angle. But I only know one side of this triangle. So I feel like I should do Pythagorean theorem, but I can't do Pythagorean theorem with only one side. Is there any way we could find another side? There is. Somebody know what it is. No. It looks like this is the same as what we did before, but in the ones that we were looking at before, like that, go all the way back here, this line went all the way across the circle. And so our problem here, this line does not go all the way across the circle. It would have to go all the way across for that to work, and it doesn't. So we can't use that. What we got to use is actually way easier. It's already given to you. It's on there. Somebody know? We do have a central angle, but we don't have to, like, do anything with an angle there. What is this right here? A radius. What is this right here? Also a radius. What do we know about all of the radii of the circle? They're all the same, right? So this is 9 right here, which I think is kind of cool, and somehow is something that, like, whenever I see these problems, I don't think of at first. So the length of this side right here, so if we're thinking about just the triangle now, the length of this side is 15, right? And that is our hypotenuse. So we would say 9 squared plus x squared equals 15 squared. And that'll be 81 plus x squared equals 225. We'll subtract 81. X squared will equal 144. So we will square root both sides, and x will equal 12. That is the reason they gave you this in pieces, where they gave you the 9 and 6 instead of just giving you that the whole side was 15. If they only gave you that the whole side was 15, we wouldn't be able to do it. All right, questions? All right, we got just a couple more to do. This is the last slide, right? Okay, so for this, they are asking us, oh, I don't think I put directions on here. The question was asking for perimeter. So, perimeter. Just need to put directions with that. So perimeter is the distance around the edge, right? So, like, when you're doing perimeter of this one, you're doing pretty good. 14 plus 15.5 plus this side would be 14.3, right? But we don't know how long this side right here is. So I have to figure that out. So, all of these are tangent, correct? So if I know this little piece right here is 4.3, what's this little piece right here also? 4.3. Now, the problem is they didn't give me this piece. If they gave me that piece, this problem would be even easier because I would just say that's the same as this and add those together and put it here. But they didn't give me that. They did give me this is 10, so that means this is 10. Hello? Yes, thank you. Rylan, at the end of this class, you are leaving, so you need to go to the front to check out. But you can stay for the rest of the class period. All right, so this piece right here is 10. So what is this piece right here? The whole thing's 15.5. So this would be 5.5. Right? If that's 5.5, then this right here is also 5.5. Right? What would we do to find this piece? 14 minus 5.5. What's that give you? 8.5? 8.5. So if that's 8.5, this is 8.5. So this whole side together would be 8.5 plus 4.3, which is going to give you 12.8. And so then if I'm looking at perimeter, I've got 14 plus 15.5 plus 14.3 plus 12.8. And that is going to give me 56.6 right there. So that would be my answer. $14 is going to be very similar, but we're running out of time, so I'm not going to go